Right now, while you're watching this video, something is happening more than 225 million kilometers away that almost nobody on Earth can hear with their own ears. A machine no larger than a compact car is sitting alone inside an ancient crater. Around it, an atmosphere just 1% as dense as Earth's is carrying sounds that should barely exist at all. It is not recording music. It is not recording voices. It is recording an entire planet learning to speak. The sounds are faint, sometimes almost silent, sometimes interrupted by wind that travels differently than any wind you have ever experienced. Imagine standing in a desert where the air is so thin that every conversation becomes a whisper, even if someone is standing only a few steps away. That is what Mars is like. And nobody expected scientists to be listening to it this way. Stick around, because I'm about to walk you through what scientists actually confirmed after Perseverance began recording the sounds of Mars. And hit subscribe now, because this channel breaks down real space discoveries without the exaggeration. Let's go back to where this story actually begins. For decades, Mars was almost completely silent. Not because nothing happened there, because nobody had ever managed to place a working microphone on its surface. Scientists had photographs, they had chemical measurements, they had weather data, they had radiation readings. But hearing another planet remained frustratingly out of reach. That changed with one engineer. In the early 2010s, French engineer Sylvestre Maurice, working with an international team developing NASA's next Mars rover, helped propose something surprisingly simple. Take a microphone, put it on Mars. That sounds obvious today. It was anything but obvious then. Microphones had flown toward Mars before. One was carried aboard NASA's Mars Polar Lander in 1999. The spacecraft never reached the surface. The microphone never recorded anything. Another microphone was included with the Phoenix mission. It ultimately never flew. Again, Mars remained silent. Engineers knew why. Landing on Mars is brutally difficult. Every gram matters. Every electrical connection creates another possible failure. Every additional instrument competes for limited power, limited bandwidth, and limited space. When designing a rover expected to survive years on another planet, adding a microphone seemed like a luxury. After all, a camera produces scientific measurements. A spectrometer identifies minerals. A weather station measures temperature and pressure. A microphone? Many wondered whether it justified the risk. But the engineering teams argued something important. Sound contains information. Wind creates sound. Dust creates sound. Mechanical systems create sound. A microphone could become another scientific instrument, not simply for public outreach, but for understanding Mars itself. NASA agreed. The microphone stayed. On July 30th, 2020, Perseverance lifted off aboard an Atlas V rocket from Cape Canaveral. Its destination was Jezero Crater, an enormous impact basin, roughly 45 kilometers across, that scientists believe once contained a lake billions of years ago. If ancient microbial life ever existed on Mars, Jezero became one of the most promising places to search. But Perseverance was carrying something no previous successful Mars rover had ever delivered. Working microphones. Not one, two. One attached to the rover's engineering systems. Another mounted as part of the SuperCam instrument, designed primarily to study distant rocks with lasers. The journey itself lasted about 7 months. During that time, the spacecraft traveled roughly 470 million kilometers through interplanetary space. Think about that distance. Driving around Earth's equator once is about 40,000 kilometers. Perseverance traveled the equivalent of circling our planet more than 11,000 times before it even reached Mars. Then came the hardest part: entry, descent, landing. Engineers sometimes call it the 7 minutes of terror. The spacecraft slammed into the Martian atmosphere, traveling around 19,500 kilometers per hour. Within minutes, it had to slow to almost zero. Heat shield, supersonic parachute, powered descent, sky crane. Each system had one chance. No second attempt, no repair mission, no rescue. Because by then, radio signals already required roughly 11 minutes to travel one way between Earth and Mars, depending on the planet's positions. By the time engineers received confirmation that something had gone wrong, it would already be over. Everything had to happen automatically. And it did. On February 18, 2021, Perseverance landed safely inside Jezero Crater. Soon afterward, humanity heard something it had never truly heard before. Not an artist's reconstruction, not a computer simulation, not audio created from vibration data. The real sound of wind moving across another planet. The first genuine recordings ever captured on the surface of Mars. And surprisingly, that was only the beginning. The recordings would reveal details about the Martian environment that scientists had never been able to measure quite this way before. One of the most valuable recordings Perseverance has captured did not come from a planned experiment. It came from weather. On Earth, dust devils appear in deserts and dry fields. They are small, rotating columns of air that lift loose dust from the ground. Mars has them too. But because the atmosphere is so thin, scientists wanted to understand exactly how they behaved. Perseverance happened to be in the right place at the right time. Its weather sensors detected a sudden drop in air pressure. At almost the same moment, its microphones recorded the sound of wind growing stronger. Its cameras photographed a towering column of dust passing nearby. For a few seconds, 3 completely different instruments were watching the same event. Pressure, sound, images. That combination is extremely powerful. It is like having 3 eyewitnesses describing the same accident from different angles. Each one notices something different. Together, they produce a much clearer picture. The pressure sensor measured the changing atmosphere. The camera showed the spinning dust. The microphone captured the changing sound of the wind. Researchers could compare all 3. The measurements matched remarkably well. That helped confirm computer models describing how Martian dust devils behave. But questions remain. Scientists still do not fully understand why some dust devils grow only a few meters high, while others rise hundreds of meters into the atmosphere. The recordings help. They do not solve everything. Some of Perseverance's most useful recordings are not from Mars at all. They come from the rover itself. Every wheel rotation, every robotic arm movement, every drill, every motor, every mechanism produces sound. That might seem unimportant. It is not. Imagine owning a car. One morning, you hear a tiny clicking noise that was never there before. Most mechanics immediately pay attention. Machines often announce problems before they stop working. Perseverance works the same way. Its microphones allow engineers to compare today's sounds with recordings made months earlier. If a motor begins sounding different, engineers investigate. If a mechanism vibrates differently, they compare it with previous data. The microphone becomes another diagnostic tool. Think of it as giving the rover another health check. Instead of measuring blood pressure or heartbeat, engineers are measuring tiny mechanical sounds. On Earth, a technician could simply walk over and inspect the machine. On Mars, that is impossible. Everything must be understood remotely. Every additional clue matters, especially when your laboratory is more than 225 million kilometers away. The SuperCam microphone revealed another unexpected detail. When the laser strikes different rocks, the tiny shockwave behaves differently depending on the material. Dense volcanic rocks respond differently from softer sedimentary rocks. Scientists expected some variation. The measurements were detailed enough to become genuinely useful. That matters because Jezero crater contains rocks formed in very different environments. Some formed from volcanic activity. Others were shaped by flowing water billions of years ago. Perseverance is trying to reconstruct that ancient history. Every rock is another page in a book that has been buried for billions of years. The laser provides chemistry. The microphone provides acoustic clues. The cameras provide texture. Taken together, they reduce uncertainty. No single instrument tells the entire story. Science almost never works that way. Independent evidence is far more convincing than one dramatic result. That is one reason researchers remain careful. When multiple instruments agree, confidence grows. When they disagree, new questions appear. Both outcomes are valuable. Before Perseverance landed, most acoustic models of Mars came from laboratory experiments. Researchers built pressure chambers. They filled them with carbon dioxide. They lowered the pressure. They tried to imitate Mars as closely as possible. Those experiments were impressive. But Earth laboratories are still Earth laboratories. Mars is different. Different dust, different temperature swings, different terrain, different winds, different daily weather cycles. Perseverance provided something impossible to create completely on Earth. Reality. Real Martian wind. Real Martian rocks. Real Martian temperatures. Real Martian sound. Some predictions proved accurate. Others required adjustment. That is not failure. That is exactly what exploration is supposed to do. Models improve only after confronting real data. Perhaps the most remarkable part is how ordinary many of these recordings seem. Wind, dust, mechanical movements, laser pops. Nothing sounds dramatic. Yet together they represent something humanity had never possessed before. An actual acoustic environment from another planet. Not imagined, not reconstructed, recorded. Researchers are still analyzing these recordings, alongside weather measurements, images, and chemical data. There is still much they cannot fully explain. How sound changes during different seasons. How local terrain alters wind patterns. How temperature layers affect the way sound travels over longer distances. Those answers will require years of observation. And perseverance is still listening. One of the easiest mistakes to make is to think the microphone is simply recording audio. It is doing much more than that. Every sound carries information about the air it passed through. On Earth, meteorologists combine temperature, pressure, humidity, and wind speed to understand the atmosphere. Mars has its own weather. It has seasons, clouds, dust storms, pressure changes, powerful winds. But its atmosphere behaves differently because it is so thin. Every gust recorded by Perseverance adds another piece to that puzzle. Imagine dropping a pebble into a pond. The ripples spread outward. Now imagine those ripples moving through syrup instead of water. They would travel differently. The same idea applies to sound. The atmosphere changes the signal before it reaches the microphone. By comparing those tiny changes with weather data from Perseverance's environmental sensors, scientists can better understand how the Martian atmosphere behaves from moment to moment. No single recording answers every question. Thousands of recordings, collected over months and years, begin to reveal patterns. That is how planetary science often works. Not through one spectacular moment, through patient observation. The sounds themselves are fascinating, but where they were recorded matters just as much. Perseverance did not land randomly. NASA selected Jezero Crater because orbital spacecraft had found evidence that a river once flowed into it. Billions of years ago, this place looked very different. Water entered the crater. It slowed down. Sediment settled to the bottom. Over immense periods of time, that process created a delta, a fan-shaped deposit, similar to those found on Earth where rivers meet lakes or oceans. On our planet, ancient deltas are excellent places to preserve signs of past microbial life. That does not mean life definitely existed on Mars. It means Jezero offers one of the best places to look. Every drill sample, every photograph, every laser measurement, every weather observation, and yes, every sound recording helps scientists understand the environment surrounding those ancient rocks. The microphone was never expected to discover life. Its role is different. It helps describe the world in which those rocks exist today. The better researchers understand today's Mars, the better they can interpret evidence from billions of years ago. Perhaps Perseverance's most important mission is not happening today. It is happening for scientists who may study these rocks decades from now. The rover is collecting carefully selected rock cores. Each sample is sealed inside a sterile titanium tube. Think of them as time capsules. Instead of letters or photographs, they contain pieces of another planet. These samples are being left in carefully documented locations or stored aboard the rover. The long-term goal is ambitious. Bring them back to Earth. Only then can researchers examine them with laboratory instruments far larger and more sophisticated than anything that could fit aboard a rover. Those laboratories can perform analyses impossible to conduct on Mars. Scientists hope those future studies will answer questions that today's instruments cannot. But there is an important word there: hope. Mars sample return remains a technically complex international effort, and its timeline is still evolving. Exactly how and when those samples return to Earth remains under discussion. That uncertainty is part of real science. The destination is clear. The path is still being refined. It is easy to forget how isolated Perseverance really is. There is no technician nearby, no replacement parts, no emergency repair team. Every wheel must keep turning. Every camera must keep working. Every computer must continue operating through freezing nights and dusty days. Engineers monitor the rover constantly. But monitoring is not the same as control. Commands leave Earth. They travel across millions of kilometers. Only much later does Perseverance receive them. Then the rover decides exactly how to carry them out safely. Hours later, engineers receive the results. That delay changes everything. Imagine trying to solve a problem over a video call where every sentence takes 15 minutes to arrive. You would plan carefully. You would avoid unnecessary risks. That is exactly how Mars exploration works. Patience is not optional. It is essential. Perseverance is expected to continue exploring Jezero crater for as long as its systems remain healthy. Its cameras will keep documenting the landscape. Its weather instruments will continue tracking seasonal changes. Its microphones will keep recording winds, mechanical sounds, and the subtle acoustic environment of Mars. Meanwhile, scientists on Earth will continue studying years of accumulated data. Some discoveries may come not from new recordings, but from new ways of analyzing recordings that already exist. That is increasingly common in planetary science. As computing methods improve, older datasets often reveal details researchers could not recognize when they were first collected. The story of perseverance is therefore still being written, not because something mysterious suddenly appeared, but because careful observation continues, one measurement at a time. And with every passing Martian season, the quiet voice of another planet becomes just a little easier to understand. So what did Perseverance actually record that surprised scientists? Not evidence of alien voices, not mysterious transmissions, not anything supernatural. It recorded something far more valuable: reality. Before February 2021, every discussion about the sound of Mars relied on theory, laboratory experiments, and computer simulations. Those models were grounded in well-established physics, but they were still predictions. Perseverance changed that. For the first time, researchers could compare prediction with observation. Some expectations proved remarkably accurate. The thin atmosphere did weaken higher-frequency sounds much more rapidly. Wind behaved largely as atmospheric models suggested. The laser microphone performed as engineers hoped, adding useful acoustic information alongside chemical measurements. But the mission also revealed details that laboratory testing alone could never fully reproduce. Mars is not simply a low-pressure chamber inside a laboratory. It is an entire planet. Its dust behaves differently. Its temperatures change dramatically from day to night. Its landscape shapes the wind. Its atmosphere changes with the seasons. Every recording added another layer to that understanding. The lesson is surprisingly simple. You cannot completely understand another world until you experience that world directly. At first glance, listening to Martian wind may seem like a curiosity. Interesting, perhaps even beautiful, but not especially important. Science rarely works that way. Every successful mission teaches engineers how to build the next one. Perseverance is helping researchers understand how instruments perform in extreme environments, how microphones survive freezing temperatures, how autonomous systems operate millions of kilometers away, how weather behaves on another planet. Those lessons extend beyond Mars. Future robotic explorers may travel to icy moons like Europa or Enceladus. Others may investigate Titan, where the atmosphere is actually denser than Earth's. Each destination presents new challenges. Each mission builds upon those that came before. Perseverance is one step in a much longer journey, and perhaps the greatest lesson is philosophical rather than technological. For thousands of years, humanity looked at Mars as nothing more than a reddish point of light. Then telescopes revealed mountains. Orbiters mapped valleys. Landers touched the surface. Rovers drove across ancient riverbeds. And now, we can hear the wind moving across another planet. Our picture of Mars did not change all at once. It became clearer, one observation at a time. So, what does all of this actually add up to? It adds up to a reminder of how exploration really works. The biggest discoveries are not always the loudest ones. Sometimes they arrive as a faint whisper carried through an atmosphere only about 1% as dense as Earth's. Sometimes they are hidden inside the sound of a laser striking a rock. Sometimes they are buried within thousands of ordinary weather recordings collected over years. That is why perseverance matters. Not because it answered every question, because it asked better ones. Researchers still cannot fully explain every detail of how sound behaves across different Martian conditions. They are still studying how seasonal changes affect the atmosphere. They are still comparing acoustic data with weather measurements, images, and rock analyses. The unknown remains larger than the known. That is not disappointing. That is exactly what keeps exploration moving forward. Mars is only one world. Our solar system contains many others. Beyond that, lie trillions of planets orbiting distant stars. It is genuinely worth wondering what they might be hiding too. One rover, one crater, an atmosphere only about 1% as dense as Earth's, a journey of roughly 470 million kilometers, a landing completed in 7 minutes, and a planet that finally allowed us to hear its voice. Perseverance continues to work today, recording, measuring, drilling, and exploring one careful observation at a time. Every new recording reminds us that exploration is rarely about spectacular moments. It is about patient ones. Because when a robot listens on another world, humanity listens with it, and every answer it sends home becomes another small step toward understanding our place in the universe. If you enjoyed this documentary, subscribe and turn on notifications so you don't miss future explorations. Here at Proof, every episode is grounded in real published research rather than exaggerated headlines, because the universe is already extraordinary enough without embellishment. Thank you for watching.